All right, ladies and gentlemen, the last video we're going to be looking at for polar equations, at least for the intro, is converting rectangular coordinates to polar coordinates. Now, I would strongly advise that you watch all the other videos prior to this before, just because they kind of follow a natural order. It's going to make it much easier for us. So remember, we're starting with rectangular and we're going to polar. So this is of an xy value. And we want to get an R value and a theta value. Way we do this, very, very simple. First, I would recommend plotting the point, just a sketch so you know which quadrant it's in, right? The first one we're looking at is 3, 0. So we go to the right we go to the right or left 1, 2, 3. And we do not go up or down at all. So the way we're going to do this very easily, first we do our R value. Here are the equations we use. R squared equals 3 squared plus 0 squared. So R squared equals 9. Take the square root. R equals 3. We're going to keep it as the positive 3 because it says we want our R value to be positive. And honestly, I like to keep the R value positive. So we know our R value is going to be 3. Oh, let me erase that. Got ahead of myself there. Our R value is going to be 3. Now to find theta, we take tangent of theta is equal to x or y over x, so 0 over 3. So tangent of theta equals 0. So to get theta, we take tangent inverse of both sides, which we'll use the calculator for. Make sure you are in radian mode here. Also, I have a video in our calculator folder as to how to access the online or our calculator emulator for those of you who have forgotten. So let me get to tangent. Second tangent of 0 is 0. So first thing, here's a coordinate. We want to check this coordinate. Now remember, here's our R, here's our theta. Our theta says we go out 0 degrees, so we don't rotate at all. Our radius says we go out 1, 2, 3. Notice we have landed in the exact same location, so this will work. We want to check this because sometimes we might have to modify our theta value. Let's check out another one, number 14. Number 14, first thing we're going to do is plot it out, right? 2 root 3 is we go to the right 2 and up 2 root 3. So we're going to be right around here, right? Nothing to be concerned about. I just want to make sure I'm in the right quadrant. It's just a sketch. R squared is equal to 2 squared plus 2 radical 3 squared. Notice how that is in parentheses. We want to square the entire thing. So R squared is equal to 4 plus, and this we can plug into our calculator, or we can just square both of them. 2 squared is 4. The square root of 3 squared is 3, so this is going to be 12. So we get R squared is equal to 16. Therefore, R is equal to 4 because we take the square root. So we have our R value. Now we check our theta. Tangent of theta is equal to our Y value, 2 radical 3 over 2. This we can plug directly into our calculator as theta equals tan inverse of 2 radical 3 over 2. So we go to check that. We plug that in and we get theta equals, it appears to be, let me double check it in my calculator, pi over 3. Notice pi over 3 puts us up in the first quadrant and our radius is 4. So you can see this is a pretty straightforward process for calculating our R and calculating our theta. Let's look at one more here. I'm going to modify one of the problems we have here. we're going to look at the coordinate, very similar to the one we did before. We're going to look at 2, -2 radical 3. So if we go to calculate, let's plot our point first, right? And this is going to be our new one. We go to calculate our point. We go to the right to, actually, let's switch this up. I don't like that one. Let's make this one -2. So we go to the left 2 down 2√3. So we're going to be right about here, right? So our r value, or r squared, is equal to -2 squared plus 2 radical 3 squared, which is 4 plus 12 again. So it looks like our r value, which makes sense, is going to be the same, right? I didn't change any of these quantities. What changed was, well, how far did we rotate? Now, we have to calculate our theta. So obviously our theta here should be different. So tangent of theta is equal to 2 radical 3 over -2. So let's check in our calculator what tan inverse of that is going to be. Second mode, let me make sure I'm in radian again, of 2 radical 3 divided by 2. Let me get, so you guys can see, I'm going to slide over onto sphere so you guys can see how I plug this. I should have showed you guys how we plug this into the calculator. Notice here, you can use the decimal approximation. I just think it's easier to use. So we plug this in. Notice how I have this all in parentheses divided by 2. And I found out that it's pi over 3, right? Oh, I forgot to put in the negative. So it's -pi over 3. Let me write that down. -pi over 3. So this would tell us theta is equal to -pi over 3. Now, I think we should see an issue here, right? Because -pi over 3 would put us in this quadrant, and that's not right. We're in the third quadrant. So the way we would find this value is if we know that we have this being pi over 3. What we need to do is we need to find the pi over 3 in the fourth quadrant. The pi over 3 reference angle in the fourth quadrant is 4 pi over 3. We just use this value to find our reference angle. This is going to tell me, because it's the similar triangle, that this is also has to be pi over 3. But in our case, it's going to be 4 pi over 3. We're just using our knowledge of the unit circle to figure out which quadrant we lie in. Guys, I hope you found this helpful. This is why you want to plot it out, because not always will this theta be exactly what we want. You got to use a little bit of brain power here. Well, I hope you guys are doing great, staying safe, being healthy. I miss you guys a ton. Have a great rest of the day.